In this video, we're going to learn how to write a polynomial function from its zeros. We're going to start off with the factor theorem. The expression x minus a is a factor of a polynomial if and only if a is a zero of the related polynomial function. We saw this in the last video, but now we're going to put it to the test because I'm going to give you the zeros and we're going to write a function from that. So knowing that these are the zeros, let's go back and find out what the factors are. So starting with this one, we have the zeros are -2, 2, and 3. So if I were to work backwards, the function would be y is equal to x minus -2, x minus 2, and I'm just following that form up top for each of these zeros, and x minus 3. So simplifying all of that, I get x plus 2 times x minus 2 times x minus 3. So this is the polynomial function that has these given zeros. But this is not in standard form, so how do we put it in standard form? Well, we're going to first multiply out these two binomials, which will give me x plus 2 times x squared minus 5x plus 6. Whenever you multiply out these two binomials using the FOIL method or the distribution method, whatever works for you. But now, how do I multiply a binomial by a trinomial? Well, the best way is just to distribute one into the other. So meaning I could just distribute x squared minus 5x into the x plus 2, giving me x times x squared minus 5x plus 6 plus 2 times x squared minus 5x plus 6. And when I distribute these, I'll get x cubed minus 5x squared plus 6x plus 2x squared minus 10x plus 12. Which when I simplify all of that, I get y is equal to just x cubed minus 5x squared plus 2x squared, so it's minus 3x squared. And then 6x minus 10x, which is negative 4x, plus 12. So that would be the standard form polynomial. Now let's look at if there was two -2's as a 0, and then 2 and 3. How different would that polynomial look? Well, in fact, quite different. Just setting it up, I'll have x is equal to x minus -2 times x minus -2. Let me erase that real quick and fix it. Because it'd be minus -2, and then x minus 2 and x minus 3. Give me y is equal to x plus 2 times x plus 2 times x minus 2 times x minus 3. So we'll see here we're getting two of the same factor. So I'll start first. I know what these three multiply together to give me. So I'll write this as x plus 2 times x cubed minus 3x squared minus 4x plus 12. And then I can distribute that cubic polynomial into x plus 2 to see what the new standard form polynomial would be. Give me x times x cubed minus 3x squared minus 4x plus 12 plus 2 times x cubed minus 3x squared minus 4x plus 12. And I can finish that distribution, giving me x to the 4th minus 3x cubed minus 4x squared plus 12x, then plus 2x cubed minus 6x squared, distributing this 2, minus 8x plus 24. And then I can combine my like terms to give me x to the 4th, then negative 3x cubed plus 2x cubed gives me minus x cubed. And then negative 4x squared minus 6x squared is minus 10x squared. And then 12x minus 8x is plus 4x, and then plus 24. So you'll see here, very different. Even though they basically have the same zeros, just one of them shows up twice. But their polynomials look very different. In fact, one's a cubic polynomial while the other one's a quartic polynomial. So this brings me to my last point. Let's compare their graphs. Because even though they have the same zeros, their graphs actually look quite different. So if I were to go graph this first function, y is equal to x cubed minus 3x squared minus 4x plus 12. I see that I have my x-intercepts at negative 2, 2, and 3. And I need to find a few points in between to graph this. Now the easy one in between here would be just 0. If I were to plug in 0 into this function, I can see that the y-intercept is going to be 12. And over here, plugging in 2.5 to figure out how low it would dip right there. And I'm just going to use the factored form to do this. So y is equal to 2.5 plus 2 times 2.5 minus 2 times 2.5 minus 3, which would give me 4.5 times 0.5 times a negative 0.5. So all this multiplied together is half of 4.5, which is 2.25, then half of 2.25, which gives me negative 1.125. So not that much lower, so a very shallow dip there. And its end behavior, since it's a positive x cubed, would be down and up. Up to the right because it's positive, and then they go in opposite directions because of the odd exponent on the leading term. So knowing all of this, down to the left means I go down to the left from this point, through that point, through the y-intercept, back down, a little shallow dip, back up, and then up to the right. Now let's look at y is equal to x to the fourth minus x cubed minus 10x squared plus 4x plus 24. So here I have my x-intercepts are all the same at negative 2, 2, and 3. And I can go through a very similar process of finding more points. So again, the y-intercept is very easy to find. It is just 24. This is counted by 5s along my y-axis. And then I have to find a point between 2 and 3. So I'll use 2.5 again. But this time I have 2.5 plus 2 twice. So 2.5 plus 2 times 2.5 plus 2. Then times 2.5 minus 2 and 2.5 minus 3. Which gives me 4.5 times 4.5 times 0.5 times negative 0.5. So again, 4.5 times 4.5 is quite a big number, but that is just going to be 20.25. And then I'm going to take half of that twice. So half of 20.25 is 10.125. And then negative half of that value would be negative 5.0615. Wait, yeah. Or 625, rather. So that y value about 5. So it goes pretty low. It's about negative 5. But now its end behavior is a little bit more interesting, because now you would suspect it would just go through this negative 2. But the end behavior, according to the positive x to the fourth, would be up and up. It's an even power, so they go in the same direction. And since it's positive, I know it goes up to the right. So they have to go up in both directions. So what happens here at -2? It certainly can't go through that, because then it would keep going downwards, and it couldn't go back up again. So let's plug in -3 and see what happens. So y is equal to -3 plus 2 times -3 plus 2 times -3 minus 2 times -3 minus 3. So it gives me -1 times -1 times -5 times -6, which is -1 times -1, which is 1, times 30. So you get 30. So at -3, it goes all the way up to 30. So the pattern for this graph is actually it goes from upwards, from that -330, and actually just touches this -2 and goes back up but doesn't cross it. It goes back up through that y-intercept again, then back down through those points. This time it goes a little bit deeper, then back up and goes up to the right. So you'll see here something very interesting happens right at that -2, 0, or the x-intercept. The big difference between the two is that, first of all, their end behaviors are different. There are 2 turning points for the cubic function, 3 turning points for the quartic function, but more ideally, at that -2 x-intercept, even though they share all the x-intercepts, at -2, for the cubic function, it just goes straight through, while for the quartic function, it just bounces off. And this actually has to deal with the fact that we get the same factor twice, which we'll talk about in the next lesson. And that is how you write a polynomial function from its zeros.